Hello, testing. Can you hear me? Hello?
Yes, we can hear you, Heather.
Okay. Do you want me to just go ahead and get started?
Yes.
Okay. Good morning, everybody. Thank you for having me speak at the Working Towards Sustainable Cities workshop. My name is Heather Williams. I am a senior project manager at WSP. WSP is a international multidisciplinary engineering firm. I've been a senior project manager here for about 18 years. My background, I'm a Purdue University graduate with a civil engineering and environmental engineering degree. And this presentation is going to be an introduction to low impact development and green infrastructure for your community. So, with that 18 years of experience at WSP, I have had the opportunity to work across the country and also in Canada. I don't think I put my Canadian clients on this slide, but this presentation is really developed from that wealth of client experience across the country. So I have worked in Indiana with several clients, and then also across the country. So you can see I've worked in Colorado, Wyoming, Tennessee, Pennsylvania. But the reason I'm putting this slide up here is that there is no one size fits all to stormwater management. There is no one size fits all to green infrastructure and sustainability integration. Each of these clients, we've taken a similar approach to process, but getting to the end goal of successful implementation of green infrastructure is unique to each of these clients. And in this presentation, I'm going to give real life examples. And most of these photographs are pictures that I've taken, projects that I've worked on. And so as I'm speaking, I'm going to give a lot of lessons learned and opportunities for collaboration throughout the presentation. And I don't know, I'm not sure if you could see my image or not, but I'm going to turn off my camera just to make sure that the slides, that you can see the slides. So, okay. Whoops. So the presentation outline today, I know I have a broad group of participants, of multiple target audiences here. So I'm going to just go through why is stormwater a problem, and then talk about the regulatory history of stormwater. And, you know, being in the stormwater industry, like any industry, we have our acronyms. So I'm going to try to stay away from using tons of acronyms and talking too quickly, because I've caught myself doing that before. So again, I'm going to start with why is stormwater a problem, and just tee it up very basically, and then go into what is green infrastructure and low impact development, and how does green infrastructure work in municipalities? What are we actually talking about? Are we talking about capital improvement projects? Are we talking about private development and redevelopment? Or are we talking about all of the above? So I'm going to really dive into how does green infrastructure work in municipalities? You know, what are the different motivators? Some communities I've worked with, it's more of a mayoral initiative where the mayor is really into sustainability and green infrastructure, and there's not really much regulatory pressure. However, other communities, there's tons of regulatory pressure, maybe coming down through the state saying you shall use green infrastructure. So I'm really going to dive into some of those different, motivators for using green infrastructure, because that helps a municipality develop the program. And then, through those, how does green infrastructure work in municipalities? I'm going to get into the why. Why is green infrastructure and LID so important? And then to end the presentation, I'm going to talk about some common challenges and solutions that we've developed by working with those clients across the country and in the state of Indiana. And, since I think this presentation is about an hour, I'm going to try to talk about each of those bullet points and bring this outline back up so we don't lose anybody. And I know I really wanted to be there in person today, but I had some personal things come up, so I'm having to do it online, and I'd rather be there. But I'm going to try to make this as engaging as possible for the audience. So let's get into the why. Why is stormwater a problem? And we're going to start with thinking about water quantity. So the amount of water coming off of the land. And so if you look at the image to the left, the top image to the left, this is natural ground cover. And if we think about natural ground cover, wooded areas, grassy areas, and when it rains, we're not going to have as much runoff coming off of this natural ground cover. So you can see there's about 10% runoff coming off of the land as compared to the image on the right, which is 75 to 100% impervious cover. So if you think about developed, downtown areas where there's a lot of impervious surface, 75 to 100% impervious surface, we're going to see more about 55% of runoff coming off of that land type. So the amount of runoff coming off of a land type is really important when we're thinking about stormwater from a quantity perspective. So when we have all of this impervious surface on our land types, we're going to get larger volumes of stormwater coming off, and flooding can occur. So this right picture is of flooding occurring. And then when we have that volume of water moving into our streams, the left picture shows severe stream bank erosion. And so that flooding and erosion are tied to water quantity problems. So again, in the stormwater world, we talk about water quantity, which again is caused by different land development practices. And the more impervious surface we have, the more volume of water is going to come off of that surface. So from a quantity perspective, we have large volumes of water moving across the land, which is a reason stormwater is a problem. And then we also have stormwater quality issues. So if we just look at a typical residential lot, you're going to have cars, pets, etc. But the main point of this image that I want you to take away is, if you look at the stormwater coming down, the stormwater is just running off of the surface, and it's going to find a storm inlet, go in the storm inlet, and then that storm inlet is connected to a storm drain. So there's no type of filtration or anything happening here. The stormwater is just moving into the storm drain, connects to the inlet, and then that's going to find our local waterways. And as the stormwater moves over the land surface, it's going to pick up things like pet waste, leaves, fertilizers, motor oil, all of those pollutants associated with just, basic daily activities. And so stormwater quality is an issue because we don't have any treatment happening. It's just the stormwater is moving into the storm drains connected into the waterways. So again, just another visual of, water quality issues happening in stormwater. As stormwater moves over the land types, it's going to pick up sediment. That sediment's going to, connect directly into the streams. We've all seen trash and lawn debris in our stream network in the great system of stormwater inlets, nutrients. This picture below in the middle here is of nutrients. Nutrients happen from over fertilizing our lawns. Nutrients are phosphorus, different things like that. So again, I just wanted to provide visuals of why stormwater quality is an issue and what type of pollutants are found in stormwater. So we're thinking about stormwater quantity and quality. And so if we think about stormwater quantity and quality, we can then progress to the history of stormwater management strategies. So, I went to Purdue in the late 90s, early 2000s, and we really learned a lot about this sort of pre-1990 design. Get the runoff into the streams as fast and efficiently as possible. So when we talk about, pre-1990, we're talking about drainage control. We do not want any flooding on our roadways. So I have a picture of just typical roadway inlet design. We're designing this for a 10-year storm to get the water off of the roadways. And then from 1990 to 2008, and these are just rough dates that help categorize the history of stormwater management, you're going to see a lot more detention basins, because then there was regulations put into place to detain and slow down the rate of discharge of stormwater. So more local flood control strategies here, detention basins. We're seeing detention for larger storm events. And then really 2008 to 2018, again, I said I wasn't going to use many acronyms, but phase 2, the Clean Water Act, Environmental Protection Agency, and the state regulatory authorities put into effect some phase 2 municipal separate storm sewer system requirements. And so 2008 to 2018, we're seeing more water quality requirements. So engineers were having to meet water quality volume requirements and treating that first flush or first inch of stormwater coming off of site developments. And so many of the states that I showed that I worked in had a similar approach to treating the water quality volume. There'd be a traditional equation, and the water quality volume would have to be treated for 80% total suspended solids. And there's different gray infrastructure techniques, which I'm going to show in a few more slides, of how that water quality requirement was being treated during that time frame. And then from 2018 to present, the EPA, or the Environmental Protection Agency, was pushing to use more natural techniques to mimic nature and use green solutions, green infrastructure, low impact development. And again, I'm going to give examples of what that is. So, when you're talking to a stormwater engineer, there's a lot of different things that can go through your mind. You can think about transportation, roadway stormwater design, think about flood design, and then the water quality aspect is just the 1 inch. So you're dealing with a smaller volume of water to be treated. And that's another takeaway from this slide. But the city of Warsaw has most of these requirements, from the 2018 in their ordinances, like many places in Indiana. So from here, again, we've gone through, why is stormwater a problem, and the regulatory history that has resulted from that. So now we're going to jump into what is green infrastructure and low impact development. And I'm going to give you some of those examples of how the water quality volume is traditionally met in the state of Indiana. And then, what we're talking about today is green infrastructure and low impact development, and how we can maybe see more of that in public and private projects. So green is the new gray. So the left-hand picture is an example of traditional gray infrastructure that is used to meet the water quality volume requirements. traditionally, I mean, I've worked in Indianapolis for years, and this is pretty much what engineers are using to meet that water quality volume requirement. So for the gray infrastructure unit here, this is called a manufactured treatment device. The left-hand picture is of a traditional, big box retailer where you're going to have a high amount of impervious surface, a lot of oils, greases, sediment. And basically your stormwater is going to sheet flow all the way to the inlet. Stormwater is going to go to the inlet, come through the concrete pipe, and then this unit here is swirling around and it's going to capture the sediment. So it's just settling the sediment out of the stormwater. And then as this basin fills up, the stormwater is just going to exit out. So there's no volume of stormwater being controlled here. It's just it's called a flow through device. And so you're treating the stormwater by collecting the sediment. And so every 6 months or so, you're going to have a vac truck come and, suck the sediment out of here and take the sediment to a landfill. And so this is working though. This is working to treat the 80% total suspended solids, which is traditionally the requirements that we see in Indiana. So I'm not saying this doesn't work. It does work to do a single thing, which is to treat the total suspended solids. It's not creating any type of aesthetic value to the site. It's not meeting any of your local landscaping requirements. It's working to treat that 80% total suspended solids. Whereas the picture on the right is green infrastructure. So with green infrastructure, you are using the uncompacted soils and healthy plants to not only reduce the sediment, but you're also reducing the volume of stormwater. So this isn't a flow through device. So again, you can see the parking lot here on the right-hand side. The stormwater is going to sheet flow through to this gravel area, which is a forebay or sediment basin to help pre-treat the stormwater and the heavy loads of sediment coming in. And then the stormwater is going to flow in to the vegetated area. And then the next slide, I have more of a cross section to show you that the green infrastructure system or bioretention area is actually an engineered system to treat a particular volume of stormwater. You can see there's an engineered soil layer here, there's a gravel layer, and then we're always designing these systems with an underdrain system so it takes those larger storm events and doesn't flood out the system. So this picture is just to show that although the image before looked just like traditional landscaping in that parking lot, bioretention is actually a designed system with engineering components. So now not only are the inlets and pipes components, the engineered soil and plants are part of our municipal infrastructure. So that infrastructure has to be properly designed, constructed, and maintained. And those three words are words that I use constantly with all of our clients to make sure that we're not just putting something into the ground that's not going to work properly and be maintained in the future. So another slide that I always like to I love to always provide in my presentations is this native plants vegetation cross section. So this is just a cross section of the root systems of native plants. You can see it's 0 feet to 15 feet. On the left here, we have turf grass, and you can see the turf grass, those roots don't even go a foot below ground surface. And if you think about a lot of our landscaped areas, a lot of the landscaped islands in those big box retailers, you're using turf grass here with no root systems. The middle, some of these middle plants like coneflower and black-eyed Susans and different things like that that are native plants are going to have a lot longer root system. And those longer root systems help to break the soil up below ground surface to help stormwater infiltrate into the ground. And then they also help the native plants be drought tolerant. So when it doesn't rain, these plants can get down to the water table to sustain themselves during drought times. So native plants are very important in the design of these vegetated green infrastructure systems because of what's going on below the ground surface. And then also above the ground surface, a lot of the native plants are pollinator habitats, create visual interest for our communities. So, you know, the 18 years I've been doing this, I always use this old school image of native plants just because it's important to know that there's a lot of stuff going on below the ground surface that, you know, we might just not be aware of. Another thing to keep in mind, I'm going to go through some more stormwater practices or stormwater best management practices. Green infrastructure falls under that. So there's a lot of different options that designers can choose from. You know, for example, I showed the manufactured treatment device or the gray infrastructure, which is a water quality best management practice, but it only treats 80% total suspended solids. Whereas if we look at this top row, this is bioretention. A bioretention area is going to not only treat the total suspended solids, but it's also going to treat total phosphorus, nitrogen, fecal coliform, and metals. So using green infrastructure techniques, you're managing the volume of stormwater, but you're also getting more of a benefit from all of these different pollutant removal efficiencies. So green infrastructure, we like to help our communities define what that means. So when I talk about green infrastructure, I'm talking about a structural practice that has been designed by an engineer. So that could be something like the left-hand picture, which are permeable pavers. The middle picture here is a bioretention area. And then the top picture here is a green roof in Indianapolis at the Nature Conservancy. And then the bottom picture here is a cistern. So all of these items here, I would categorize as green infrastructure practices, and they're structural practices. And then a lot of times you'll hear low impact development. And so when I refer to low impact development, I'm talking about non-structural land planning practices, whether that's protecting existing trees, protecting riparian buffers along a creek side here. This is the top right-hand picture. Or the bottom picture is making sure that your ordinances have a conservation subdivision ordinance where we see cluster lots, more narrow streets, and larger contiguous forested areas being protected. So low impact development is more non-structural practices. And then when I say green infrastructure, I mean structural practices that are designed by engineers. So again, this is my language. This is what I speak every day. I know we have different people in the audience, so this might be something new, or I could just be speaking with stuff that you know, but I just want to lay out the terms just so we're all on the same page. So now we're moving on to, you know, I've laid out the regulatory background, what is green infrastructure and low impact development. Now we're moving on to how does green infrastructure work in your municipalities? So from policy, planning, design, construction, long-term maintenance, you know, what are some of those motivators that municipalities have to integrate green infrastructure? And then what type of projects, public, private? So I'm going to go through some of these items now with some examples of projects that I've worked on, and I'll try to explain those projects and get to and outline those 3 bullets with explaining the projects. So all of these projects are public capital improvement projects. that I have worked on. The top left-hand picture is what I want you to focus on now. This image is from Knoxville, Tennessee. Knoxville, Tennessee is a client, and Knoxville wanted to integrate green infrastructure into some of their capital improvement projects and planning processes because their state permit was requiring them to do that. So it was more of permit driven. The top picture, you can see there is a concrete, let's see, I wish I had a little pointer, but this is a concrete channel leading directly to that storm inlet. That storm inlet's going to collect into that larger drain system, you know, what I explained earlier. So this isn't doing anything for water quality, nothing. This is a conveyance design, and the conveyance design is not treating water quality. It's just getting the stormwater off of this older residential neighborhood. So this would be considered, this is another term that we use as a retrofit. So this is just a rendering of the image, did a bioretention bump out here to treat the water quality, but they also in Knoxville worked with their transportation department to make a traffic calming device, because this neighborhood had issues with speeding. And so they wanted to make sure that these bioretention bump outs functioned as a traffic calming device as well. And so we're getting a water quality benefit by slowing the water down and controlling that volume. They've selected native plants. So the native plants are going to create a pollinator habitat. And then we're also getting a traffic calming device. So this was a retrofit from going from just a stormwater conveyance to an actual urban amenity. And so you can look at this, you know, what Knoxville started doing was looking at this from a systematic perspective. Okay, if we have this many residential collector streets that we're going to be redoing in the next 20 years, how many of those can we actually, you know, put these bioretention bump outs in? And how can we pilot this program? So that's an example from Knoxville. This middle image is a green ditch program that we were helping Bloomington, Indiana develop. And so this is still in the beginning phases of the thought out process. But the idea here is ditching is a common practice that all municipalities do. And typically you'll use riprap in your conveyance systems. So again, this ditch is primarily acting as a conveyance system. You're not really getting much water quality treatment. The idea is to create standard operating procedures where instead of doing the riprap, we have a planting template for native plants to plant the ditches. So we're calling that the green ditching program. The right-hand project here is a project that's actually designed, constructed, complete. We did this design in 2010, so it's been in the ground for a while. This is a neighborhood in Indianapolis. This is in Broad Ripple. The top picture shows that there was significant flooding happening in this neighborhood. And we used pave drain, and pave drain is a permeable pavement product. And I'll show you a cross section of that here in a second. But basically we used pave drain throughout 8 blocks of this residential neighborhood to treat that first flush of stormwater, the 1 inch, but then this is connected to a larger system. So we're doing 2 things here. We're treating the first flush, the 1 inch of stormwater, but then we're also conveying the stormwater. So it's helping with water quality and flood control here on the right hand side. So again, these are all capital improvement projects that we've helped different municipalities sort of green up their capital programs. This is an example of that pave drain system the top picture is not the example of the paved drain. This is an example of how roadways are traditionally designed. You can see that the surface drainage is just going to collect into the inlet, and then this inlet's going to go to a storm sewer. Whereas the paved drain, it's the surface drainage is going to go off into the paved drainer system. And then you have about 2 feet of a stone aggregate that collects and slows down the stormwater, and then it's going to be collected into a larger storm sewer system. So you're getting that time, the volume to collect in the stone storage aggregate below. So this is a project that's actually been built, and it's a project in Peoria, Illinois. And the motivation behind this project and WSP having a contract in Peoria is Peoria, Illinois had a consent decree because they're a combined sewer overflow community. So they had to develop a long-term control plan to tell the EPA how they're going to eliminate these combined sewer overflows. So it's when, stormwater and sanitary water overflow into your local waterways. And so they hired us to help come up with a solution to manage the volume of stormwater that was being combined into the combined sewer system. And so Peoria is the first community to take an approach to use green infrastructure to help eliminate their combined sewer overflow issues. And so we looked at several miles of roadway in Peoria to put bioretention areas in to manage that volume of stormwater and keep the volume of stormwater out of that combined system. So we had to put together tons of data showing how these systems are working to eliminate those volumes of stormwater going into the systems to eliminate the overflows. So this picture is of a bioretention bump out being constructed in Peoria. And, a lot of challenges that arise with these bioretention bump outs in ultra urban areas is we're going to have a lot of utilities in the way. We're going to have urban soils that are not conducive to grow vegetation in. There's going to be higher sediment loads. So all of those things are factors when you're designing bioretention, and those factors can be addressed through your standards and through guidance material. And then another item, since we've been doing, since WSP and myself and different ones of my colleagues have been, designing green infrastructure for a long time, there are lessons learned that we've, found and, maybe designed something not quite right. But this one, so this bioretention area, we made sure to put pedestrian crossovers in. So you can see up here in the top right-hand corner, if you're going to have parking spaces next to bioretention, you need to be able to move people across the area. And so that's one design thing, make sure you think about pedestrian movement. And then another item is always try to think about education in your design. And so for Peoria, since they're using taxpayer dollars to help solve the combined sewer overflow problem, and really the way you solve that problem is trying to eliminate volumes of stormwater going into the system. And so the bottom right-hand picture here, it says 46,300 gallons, and that's stamped into the concrete that is the protection zone of the bioretention area. So having that forethought in your design and making sure you integrate that educational piece is very important, especially for huge public projects like this one. And so I love sharing that picture. If there's any designers in the room, just think about how can we integrate education in these stormwater systems to help the general public understand that it's more than just infrastructure. This is helping communities. This is beautifying communities. So again, This is Peoria, Illinois. Their major motivator was the combined sewer overflow program in their long-term control plan. And this is just giving you an example of the turf grass and native plant slide that I provided earlier. This left-hand picture is just your typical landscaped island. You see there's a continuous curb around the landscaped island. We're using turf grass. And, you know, all those municipalities that I listed earlier, if most of those municipalities will look at their landscaping ordinance, and this is what can meet that local landscaping ordinance. So we always do a deep dive into a municipality's landscape ordinance, try to open up opportunities for incentives. So if you meet your landscape ordinance requirement with something like the right-hand picture, bioretention, where you're meeting a couple of the objectives of a municipality, you're meeting that landscape requirement, and you're meeting your stormwater requirement, we try to provide incentives for that. So you can see the right-hand side is the same stormwater or the same landscape island, but now we're using it to function as a stormwater best management practice or green infrastructure. And you can see, again, these are design systems that municipalities have to create standards for. You know, how big should the curb cut be? How much inflow can that curb cut take? How do we design this pre-treatment area to make sure that sediment doesn't clog the basin? What type of native plants work for your community? How about the overflow structure? We don't want this, we don't want bioretention to be saturated or to have ponding depth for more than 48 hours. So you have to make sure you design that overflow structure. So there's so much thought that goes into designing bioretention. And, you know, you can, again, like we've worked with a lot of communities to create educational material and to create engineering guidance. These are some private new development and redevelopment examples. So the left-hand picture here is of Fort Wayne, Indiana, and their riverfront redevelopment. This building here is a mixed use development, has residential on top with commercial on the bottom. But I like this image, and this is an image that I took because it just looks like a natural, it just is very inviting. You know, they're using native plants in a controlled way. It's not overwhelming. It just is a nice, inviting design. And then, you know, the public signage here, branding your signage with, they have a riverfront redevelopment program, and making sure as you walk, you understand that this is an engineered system treating stormwater. The picture on the right is not in Indiana. If you see the mountains in the background, that is not from Indiana. You know, one good thing about working for WSP, being an international national company, is I get to work across the country in really nice places. So this picture is from Boulder, Colorado. We developed a green infrastructure master plan for Boulder. I think I worked there for five years because we developed their master plan and did a lot of implementation items. And one implementation item that Boulder did was a long-term maintenance program. The state permit in Colorado had a very, very stringent requirement for maintenance for both private and public green infrastructure practices and just traditional stormwater practices. So that's a challenge that I might talk about a little bit later. But again, Boulder, this is a picture from Boulder, Colorado. This is a more utilitarian type design of a bioretention area in a municipal parking lot. Just another image showing you the complexity of the green infrastructure design system. You know, it might, to just a, average person walking by, you might just think it's nice landscaping, but there's actually a lot of work being done. And many of these systems aren't purely infiltrating. They're designed to capture that 1 inch of stormwater, but then there's always an outlet structure taking the extra stormwater to the overall storm drain system. This picture is just to show that you can have multiple green infrastructure practices in series. So here you have a green roof. The green roof is going to go down to the permeable pavement, and that's going to be connected to the vegetated swale. And then you see the stormwaters, going, this is a permeable pavement system. So the stormwater is going down, and it's just this sort of cascading system managing the stormwater, but you're going to have that overall collection system going into your municipal system. So again, a lot of times people are like, hey, green infrastructure can handle, larger storm events or it can help with flooding, but it's not going to be your 100-year event safety net here. So that's why a lot of times you're going to have an under drain system in the design. Again, I've just included some images below just to show you different ideas for integrating green infrastructure into, your private or public projects. And so getting back to the multiple benefits of green infrastructure to land development stakeholders, you can visualize that gray infrastructure or manufactured treatment device, that's just treating the 80% total suspended solids, whereas, the green infrastructure practices have benefits to the city, to the land developer, to the property owner, and to the community. For example, when you use green infrastructure and low impact development, the land developer could see reduced land clearing and grading cost. If you're preserving natural areas, that's going to be areas that you're not going to have to grade or clear. May reduce infrastructure cost, where if you are managing that first inch of rain, you might be able to get smaller pipes, may reduce construction materials and maintenance costs. So, when you think about green infrastructure, think about the multiple benefits to the different land stakeholders that go beyond just that gray pipe, go beyond the 80% TSS removal. And so one thing I've learned from doing this work, although I am a civil engineer by education, I view myself more as a coordinator, because green infrastructure touches so many different departments in a municipality. If you look at any municipal's comprehensive plan, typically the comprehensive plan is going to support green infrastructure. And then you look at the streets, parking, and transportation plans, and typically those you're not going to see much green infrastructure integrated into those. So there's so many different planning documents at a municipal level that need to be coordinated, and collaboration needs to happen between the various departments to really figure out, what are the priorities of the municipality, and how can we start overlaying some of these different plans to integrate green infrastructure. And so, I just like to show that, initial slide because of all the clients that I've worked with at WSP. And, currently I'm working with Jackson, Wyoming. And, you think about Jackson, Wyoming, and the amount of wealth that is in that community and the lack of regulations, is really surprising. But even Jackson, Wyoming, they're at a point where they, contracted us to put together a stormwater program master plan. They don't have a funding source for stormwater. Their ordinances are not, they do not have construction site or post-construction site ordinances. And so the reason I bring up Jackson is because it's a current client of mine, and we always take our clients through this green infrastructure roadmap planning process. So what are your green infrastructure goals as a community? Why are you doing this? What is it, to protect your natural resources? Is it because your state permit requires you to? Is it because the mayor is interested in this stuff? Or, it could be all of the above. And all the communities we work with, the goals are always different, but we always want to learn what those goals are. And then looking at this little yellow tab here and looking at the examples that I provided, it's so important to make sure you have your feasibility criteria set up, your design standards set up, your construction ordinances and policies, and your land development code changes. So, once you have your goals, then you sort of look at these type of items to make sure that the green infrastructure is constructed and designed properly. And then what about your maintenance policies? Do we have funding for maintenance? I think I was alluding earlier to the Boulder, Colorado client who Boulder they have a stormwater utility, they have funding. And so with this new permit requirement, they just added one new staff to run their maintenance program. The city of Bloomington, Indiana added a green infrastructure maintenance crew to help with their maintenance. So these are different examples of how some communities have dealt with the maintenance issues that arise with green infrastructure. And then, conversely, the city of Indianapolis privatizes it. So they just contract out all of their green infrastructure maintenance to a firm that understands how to do it. So there's different ways and different policies that you can create. And then, how do all of these things impact your resource needs and your budget? And so then we get on to the implementation. But I just like to have this, I like this slide because we don't just start designing green infrastructure. Like we'd like to take communities through this plan so you can have successful implementation. And so what is a green infrastructure roadmap? The green infrastructure success requires a balance of stormwater regulation with permit responsibilities for water quality protection, local goals for economic growth, local goals for community water resources, stakeholder desires for land development flexibility. Currently in Jackson, Wyoming, we're working with an external land development stakeholder group, of their concerns with imposing, more regulation in the community. So it's always good to get your stakeholder groups lined up early. And then what about the physical, financial, and administrative feasibility of GI, the design, construction, and maintenance? Infiltration doesn't work everywhere, so we want to make sure we have those feasibility criteria set up. And the roadmap process evaluates these factors to determine strategies for community change. And essentially, it's a strategic plan for green infrastructure. So I just wanted to throw these two slides in just in case there's some municipal planners in the room, and knowing there's a process that we typically take for green infrastructure integration. So now we're coming to the end of the presentation, and I was supposed to be an hour and it's about 10 o'clock. So I'm going to continue on and try to finish up here in the next 5 to 10 minutes. So, when we're taking municipal clients through green infrastructure, there's always a set of challenges and questions that come up. For example, which green infrastructure practices are right for us? Should we provide incentives? Where is green infrastructure feasible? What's allowed on residential lots in the public rights of way? Does green infrastructure conflict with city code and ordinances? Should we require or encourage native species? How specific should our plant specifications be? If you do have a stormwater utility, should we provide utility credits? Who does the construction inspections? Because construction inspections for green infrastructure is different. It's going to take a different set of skills than, construction inspection for placing pipe. And so a lot of times, the examples that I provided before, a lot of times municipalities have to hire different staff for green infrastructure maintenance and construction inspections. And then who ultimately is responsible for long-term maintenance? Should that be the private property owner? Should that be the municipality? And that's, stuff we help communities think through. What training, equipment, and support tools do we need? So are there vac trucks that we need to help with cleaning out the permeable pavement? These are all questions that we help clients, go through. So a lot of thought goes into green infrastructure program development. And yeah, the top right-hand picture here, again, this is a picture of a project that we helped design for Boulder, Colorado. So this is not in Indiana. Design challenges, we help communities come up with creating the correct soil amendments for your engineered soil for bioretention, making sure that the plant selection criteria fits your community's needs. And then, what type of infiltration testing is needed if if you do allow full infiltration for bioretention, and then, just that bedrock separation, making sure that the system is separated from bedrock. So there's different design challenges that come along with bioretention. We create design manuals and policy handbooks for clients to help address some of those issues. I've just provided some examples, City of Topeka and Bloomington. Another thing that our clients struggle with is green infrastructure in the right-of-way and not having municipal standards or typical details for green infrastructure in the right-of-way. This is the City of Chattanooga and Hamilton County. So this is a Tennessee client that I worked with probably, time flies. I think this is, I always think about pre-pandemic versus post-pandemic. And I think this, anyways, this was done in like 2016, 17 timeframe. But this is an image of just another opportunity here. This is we did a whole set of green infrastructure right-of-way typical details, but I like providing this one because this is a roundabout. A lot of communities are integrating roundabouts in their transportation design. So how about we have the roundabout function to treat stormwater? So this is a bioretention roundabout. And so anyhow, this is just a detail. This is one detail that we put together of a series of details for the City of Chattanooga and Hamilton County. This is Bloomington, Indiana. We looked at their transportation plan and did high-level review of how they can plan for integrating green infrastructure into their transportation plan. You can see this is just using bioretention and permeable pavement. And, the planning process, this is just creating really high-level planning images to put into, their 20, 30-year long-range transportation planning document. So just doing simple things like this helps start the conversation. And then a lot of the images that you saw that I provided, like the City of Fort Wayne, there was signage at the bioretention area. A lot of our clients require private projects have signage to simply say this is a bioretention area, no dumping, no trash, no mowing. So, it's just something to think about, how you want to, integrate signage into your green infrastructure design requirements. And then requiring BMP or green infrastructure protection in the design. I wish I had, now that I think about this, I do have a picture of a car driving into a bioretention area in Indianapolis, but I didn't include that. But protection is meant to, prohibit cars from going into the bioretention areas or people from going into the bioretention areas, or lawn mowing equipment from going in. So just thinking about how to protect, how to create protection requirements in your design manuals. And then making sure you outline and require operation and maintenance plans. Your operation and maintenance staff are going to be a lot different than your engineering staff. So we at WSP have started creating, really easy to use operation and maintenance standards and guidance material for your landscaping staff and your property owner who's not going to know they have for your private property owner who's not going to know they have a BMP on their property. Providing vegetation design support. A lot of times the civil engineer that's designing the gray infrastructure, the manufactured treatment device, isn't going to know about plant selection. So, making sure that you have a lot of guidance on plant selections with pictures, include sun, water, and upkeep information, vegetation templates, and then requiring the vegetation warranties for the developer. And then just, this is an example of some planting guidance we put together for Bloomington, Indiana, just giving general planting technique examples, mass clumpings, defining the edge, maintaining that sight line, and the appropriate number of species. And again, this is just material out of the guidance that we've put together. And so presentation takeaways. It's important to establish an internal municipal staff working group to develop a green infrastructure roadmap and/or updates to your post-construction program and any other ordinance updates that you need. So really getting a team internally at your municipality established to start laying out some of those items. Don't put vague permit language in your ordinance. Create adequate support material for green infrastructure implementation. So, sort of the stuff that I just showed you, creating that support material to lay out how you want the green infrastructure to be designed, constructed, and maintained. And then learning from pilot projects. So I know Aaron's going to talk about some projects that are happening in Warsaw next, and learning from those pilot projects and then updating your standards with those lessons learned from the pilot projects. And something that I always like to end with is the green infrastructure life cycle really starts with planning, and you have to think through all of these different items. So planning, design, construction, and long-term maintenance. And with that, I will hand it back over to Brandon and take any questions that you might have for me.
Okay, Heather, do you mind if I unpin or pin you on here?
No, I don't mind. Yeah.
People can see. Oh. See if that works. Okay. Okay, so if anybody has any questions for Heather, I can either ask for you or hand you the mic, but we'll go ahead and take questions now. Okay. 1 second, Heather.
Okay.
Find out. Yeah. Hi, Heather. Can you hear me?
I can.
Great. Well, let me just start off by saying I'm really impressed with the work that you've done and that your firm has done. It shows a very high level of sophistication in this field. One of the, I guess my question is, do you have cost analysis? So I'm very much in favor of the green approach, but when we're trying to sell this to municipalities who are in largely financially in distress, the biggest selling point could be, for example, in the Peoria project, and maybe did this, they could either spend $15 or $20 million to create a pre-treatment facility, or they could spend $5 million to use green solutions, and it's just a simple economic. There's an economic benefit beyond all the other intangibles, and so my question is, your firm is large enough. Do you have that project database to be able to put real numbers to the cost savings?
Yeah, and your point, you picked up on a point that I probably didn't make, but with Peoria, we had to show the trade-off cost. They weren't doing green infrastructure because it's the good thing to do. They were doing it because it saved them money to not do deep tunnels, right? So, okay, so that's that. And then I think on that slide, I work with Philadelphia, and Philadelphia is another combined sewer, combined sewer overflow city that has a long-term control plan. And Philadelphia is the same way. It makes way more economic sense to manage the stormwater that way. But for some of the more stormwater programs that I work on, we do put cost analysis together for some of the design manuals that we've done, where we say, okay, here's the green versus gray. And we've done that for Indy. We did it for Birmingham. So I could share, the presentation will be available that I put together. And then based on this question, I can share some of those numbers that we've come up with for this work, for municipal stormwater program planning. I don't really think, for the combined sewer overflow stuff, that's sort of a different economic analysis, but more for site planning, for meeting your post-construction stormwater regulations. We have some cost scenarios that do green versus gray and show how green infrastructure can save the developer money. So I'd be more than happy to share that with this group and with Brandon.
Okay, do we have any other questions? All right, Heather, thank you so much. I guess we can let you go now. The presentation was outstanding, and yeah, thank you again.
Oh, you're welcome. I was going to stay on and watch Aaron's, if that's okay. Or does he have it? Can I watch it, or should I get off?
I have it on PDF, so I can throw it on the screen. Would you like? Yeah, we'll probably take 5.